Okay, in this video I'd like to demonstrate the use of an edge finder. An edge finder is used to pick up the edge of a part. So if you're looking for the edge in either the Y or the X axis, an edge finder is a really good tool to use for that. The reason why you would be looking for the edges of a part, a lot of the times on your blueprints, your holes are located from a certain corner or a certain location on the part. So an edge finder is just simply a spring-loaded tool. The tip of the tool, we can measure the size of that and we know how big that is. So if you want to be able to locate the center of your machine on a certain feature on this part, you can do that. The edge finder I've selected today is a 3/8 shank, and I'm going to use a 3/8 collet. You could use an edge finder in a drill chuck as well. The problem with a drill chuck is it makes everything just a little bit longer. Some people think that a drill chuck's not as accurate as a collet. Really, that doesn't matter with an edge finder. If you don't know how an edge finder works, basically they're spring loaded. So what happens is, when you come up to the part, you'll see it, it'll run out, it'll wiggle off center, and as you get closer to the part, it'll run true. And then you have the edge just at the moment where that slides off center. So you'll have to watch pretty close here when I'm doing this. So let's put the collet in the machine. Now, since we're not milling, we can actually start to pull the quill out of the machine. We can pull the quill down a little. That'll save us from raising and lowering the table. And if I want to find the edge first in the X direction, I'm going to push it off center on purpose with my finger. Edge finder runs about the best at 1,000 RPM, so I'm going to switch it to the set speed. You see now how that thing is actually, it almost looks blurry because it wiggles so much. As I get closer to it with the part, you will see that it runs more true. Now it looks like it's running true, but we don't know exactly where it's at. So I like to go just until it slides off center. As soon as you see it jump off center, that's the edge of the part. So I'll zero it there. So once again, we're going to go X0. Zero's the display. And I'd like to do it one more time just to make sure. So the edge of the part would be at the edge of the edge finder, just as soon as you see it slide off center. And it repeats, it's zero again. So when I did that now, that puts the edge of the edge finder at the edge of the part. What we're really trying to do here is get the center of the machine or the center of any tool at the end of the part. So in order to do that, you have to know how big your edge finder is. And the one I have today is a 3/8 shank with a 200 thousandths diameter tip on it. So if you were to measure this with a micrometer, it would measure 0.2. So knowing that, how far would you think I'd have to move that to get it on center? If the tip is 0.2, you'd have to move it 0.1. When you move that 0.1, that puts the edge finder right, the center of the edge finder right on the end of the part. So after you make that movement, zero it again. Now your X0 would be set right at the end of the part on the center of the machine. You can do the same thing for the Y-axis. I'm going to do the exact same thing. I'm just going to hit it with my finger. And you see now it's blurry again, or it's wiggling. And the closer the part gets to it, the more true it runs. And you'll see it slide off center just slightly. That's the edge of the part right there. So I'm going to go Y0 this time. So now it's F5. And that's Y0. So I can now raise the spindle up. Remember, you got to move half the edge finder, so come towards the edge finder, 0.1. So at 0.1, I'm going to zero it again. So now if I take the machine and I put it at XY0, that should be the corner of this part. So XY0 right now lines up with the corner of this part. Now it depends how your blueprint is drawn. If your blueprint is drawn where the other corners are your XY0 on the print, then edge find to find these surfaces to be zero. It's a lot less math than trying to calculate from the other side. So let's just say for today's example that I'm going to put a hole in there. Let's see, my part measures 1 inch that way. So if it's 1 inch on the Y-axis, let's just say I put my hole in at a 1/2 inch on the Y. I'll come in a 1/2 inch in from the end too. So from this corner, I'm going to come up a 1/2 inch and over a 1/2 inch, and that'll be the location of my first hole. So on the readout, that would be 0.5, 0.5. So I'm going to go 0.5 on X and 0.5 on Y. So when you're at that location, if you were to take a drill now and drill that hole, that would be the location of that hole. Now to locate the hole, just like when you drill any hole, you want to usually center punch it first. On this machine, I'm going to use a center drill. It's the same center drill you'd use on a lathe. With that center drill, I can go to that hole location of 0.5, 0.5. Once you're at that location, clamp the table, and you can go ahead and center drill that first hole location. So the center drill is going to run at about 1200 RPMs. Now I can use the quill just like you would on a drill press. You can actually use that to drill the hole. So I just touched the hole, and let's measure to make sure that that's right. So that hole should be 1/2 inch in and 1/2 inch back. So an edge finder is a very useful tool to find features on the part, whether it's the front face, the back face, this end, or this end. This example, I did this end and this face, so I found this corner. Just make sure that when you use your edge finder and you touch the edge of your parts, that puts the edge of the edge finder at the edge of the part. You have to then raise up your edge finder or lower your table and move in half the edge finder. So it's important to know what size your edge finder is. Some edge finders are 200 thousandths like mine. So since mine measures 200, I offset 100. They make some edge finders that are 3/8 straight the whole way. So if you have a 3/8 edge finder, you'll have to move over 3/16 or 0.1875. There's also 1/2 inch edge finders out there. The 1/2 inch edge finder, you have to move over the radius of a 1/4 inch. So just be careful and know what size your edge finder is. It's a common mistake where people are used to using a certain size edge finder and they grab a different one and they make a mistake on their hole locations then. So edge finders can be used to locate for holes, locating for slots, anything, any feature you have to put within this part, you can use an edge finder. The next thing I like to talk about is cleanup. When you're done at the end of the day, we have to get these machines cleaned up for the next class. So make sure you take your part out, take your parallels out. If you have any chips in the vise, make sure you brush out your vise. I stress that you don't use compressed air for cleanup. I know a lot of people like to do that. With compressed air, while you're cleaning up, you could be blowing metal shavings through the air and you could stick them into your neighbor. So make sure you don't do that. If you have tool boards on there, a lot of your chips will collect on the tool board and you can just dump those right into the waste can or the recycle bin. So brush down your machine, brush out your T-slots, make sure you get all the chips off of here. The other thing I ask is that you remove the tool. I want the spindle to be empty at the end of the class. So remove the tool, take your cutting tool out of the chuck. If it was a collet, you take your end mill out of the collet and make sure you put your stuff back in the collet rack. Your vise handle should be just laying on the table and take all your other stuff with you. Don't forget the back. A lot of students forget the back of the machine. You want to brush this away back here. There's going to be chips back there. Brush them onto the floor. So you get everything all brushed down. You'll have to take the machine, take a broom, wipe off the base of the machine. Just sweep it off with a broom. And you have to sweep the whole area around your machine. You can figure pretty much a 5-foot radius around your machine are the chips that you made. If you just take a look around here quick, you can see I got a pretty good mess of chips here just from this demonstrations today. So, all right, work safe, and if you have any questions, talk to your instructors.